All right, so welcome everyone tonight. My name is Jeff Fudge. I'm the organizer here in Tampa of the Tampa Bay AWS User Group. We've been a group for about 3 years now. Welcome everyone. And if you get a chance, if you haven't already, I love people to have a chance to introduce themselves. I'm interested in your name. If you want to put your company, that's great. If you want to put your location, we love to see when we branch outside of just Tampa Bay. This is a time for us to reach anyone who's passionate about AWS and the cloud. So I appreciate you guys doing that. I'm also happy to announce, those of you that weren't here last time, IO Associates, a great cloud staffing agency, has joined and partnered with me on this. Love them bringing their passion for the cloud and for the technology side of all things cloud. So at this point, I'll turn it over to you, Sam, and others from IO Associates.
Hi guys, for those of you that were here last month, same guy, similar pitch. For those that are new, yeah, we're IO Associates. So as you can hear by our voices, we're British born, but I've taken the plunge over the past 8 months to go across the water and set up our HQ in Tampa. So we're a recruitment partner, and what that means, I guess, is resourcing, and working with clients and candidates and mixing the two, but also giving back to the community and injecting our knowledge and passion for what we do into things like this and facilitating things, organizing things alongside the likes of Jeff, etc. We specifically focus in cloud. So that's across GCP, Azure and AWS, hence why we're heavily involved in this. And yeah, we quite enjoy it. We understand 20% of what's been said, but we're getting there. We're not developers ourselves, but we do understand it to a certain degree, and we love being involved in these. And thanks very much for having us. And we'd like to think we're adding some value and impact across everyone. And guys, we're a recruitment partner, right? Based out of Tampa. All the opportunities are going to be based local. So there's anything in the cloud space that you're looking for in terms of any advice, want to know where your salary hits versus anything else, opportunities that are local to us, we'll make sure we put our contact details out so you can connect with us on LinkedIn and we can have greater conversations about individual opportunities that may suit you. There's a couple of companies we're working with at the moment that are really exciting that I'd like to talk about potentially a little bit later as well. But I don't want to take the shine off Austin too much. He's the man of the hour. So he's going to be talking to us about data lakes and architecting.
Fucking minimizes.
Yeah, I'll hand you over to Austin. If you've got any questions in the meantime for any of us, please shout out about it, and we'll talk at the end of the talk.
Sweet, thank you. Yeah, so this is kind of a first for me, not as far as doing a talk, but I'm doing a live stream to my meetup group. If you guys on the Tampa side haven't heard of it, if you go to AWS Meetup Group on their meetup.com, we're going to meet up out here in Denver. And then for everybody on my stream, I'm also working with
this computer. It's like it just freezes. Now it just doesn't do anything.
I'm working with the AWS Tampa user group, and we're going to present the data lake today, and working with IO Associates. So guys, check them out. My name is Austin Lovelace, for you who don't know. I'm a solutions architect right now at Cloud 303. I'm just recently, earlier this year, was invited to join the AWS Hero community. And like I said earlier, I'm the founder of the AWS Meetup Group out here in Denver. And unfortunately, due to COVID, we had to stop. But earlier in the beginning of the year, we were traveling around the country and teaching everybody about AWS and intro to different courses and things like that. So leading into what we're doing today, this is going to be kind of an high-level overview of data lakes on AWS. I have a data lake that's already built out in my AWS account that we'll go over. We'll talk about basics of what is a data lake, why would you need one, comparing it to a data warehouse briefly. And then I've got a full repo built with instructions of how you could replicate this in your own environment. And all the code is in that GitHub repo, which I posted in the chat of the Zoom chat and in the YouTube stream, if you guys want to go check that out. So first off, what is a data lake? So before we get into our, let's just go straight into what is a data lake, give you a little bit of an intro of like what that is, and then I can talk about some real world experiences I've had with it. So you can think of a data lake as a way that you can store multiple different types of data all together in one centralized place. And for us, we're going to be using S3 for that, Amazon's proprietary service for storing just files and images and things like that, just a bunch of all kinds of different files and everything. So we're going to store a bunch of JSON data using the Starwars API for this example. And so we're going to store all this data in a centralized repository in an S3 bucket. And we're going to have a bunch of different file formats, and we're going to structure it. And we're going to have one file format that's JSON for our example. And we're going to mutate that data and turn it into Parquet. And this Parquet data is going to be more of like column format so that it's quicker and cheaper for us to query whenever we're doing big data analytics. So you would use a data lake if you're wanting to have some serious analytics over like large scale masses of data and you needed a cheap place to store it. Then you put it in S3 and then we can do some conversions. And then we can go over like all kinds of different analytics based on that data and have a data scientist do that or a data analyst. So kind of jumped a bit ahead, but that's kind of why you'd want a data lake. And so going over this again, saying that we need some serious analytics on a new product that we're going to release, or for the example I have for today, I took this open source Star Wars APIs and I have planets and people and starships, and I took all that data for the last multiple days and I've been querying it multiple times, although the data is the same. It gives you the idea of what the data lake would do. And so for every 10 minutes, we've been querying that data using a Lambda function. We put that data in S3, and then we can convert it using AWS Glue. And then after that, we're able to analyze our data and see, like, if you wanted to compare Star Wars, Starship and people versus Star Trek, then you would have like a data lake of all the Star Wars people and all the Star Trek people, and you could compare them together and you could do some analysis on that. So that's a big reason for why companies want to use a data lake. And at my last company, the reason we had to build a data lake, I was working at a company called Photobucket, and they needed a solution for their different payment providers. And so they had probably like 6 or 7 different payment sources between iTunes and a company called Braintree and just a bunch of different other sources like PayPal. And what we would do is we'd either have webhooks or API calls that would run on like a cron job daily or hourly or whatever it may be. And we would take that data, put it into S3, and then we would want to say how many people did we gain this month or how many people did we lose this month, so we could have like business analytics. How many people did, like what is our average, like what's our ROI, what's our revenue, all that different kind of stuff was a use case for our data lake. And so we just had all these different resources come in, throw it into S3, have all the raw data, do some mutations, and we're able to tell what's going on with our business. So that's pretty much where my background of using a data lake has came from. And so if you're wanting to compare that to like a data warehouse, so data warehouse is going to be optimized, and you're going to basically clean up all your data beforehand before putting it into the data warehouse. Whereas in the data lake, you're going to take your data as is, throw it into S3 bucket, and it's just going to be all the data that you have in general. Whereas in the data lake, you're going to go ahead and structure it, or in the warehouse, you're going to go ahead and structure it, format it the way you want, and it's going to act as like the single source of truth. It's going to be already enriched, and then you can do your analysis there. Yeah, if anybody has any questions before we start digging into a lot more things, you guys could go ahead on the Zoom call, just interrupt me or put us in the chat, and then same thing on the YouTube stream, just throw a question there. And I like to keep it dynamic if possible, so that we can just have like almost a conversation while we're talking about this, rather than me just preaching just a little tangent real quick. But this is something I pulled off Amazon's docs. I think I put a link to this earlier. Most of this is copy pasta from that. But if you go to this link, if you guys are able to type this out or go back on the stream, and if you wanted to see where all of this resources I'm talking about is coming from, this is where it's at, this Amazon Big Data Lake, talking about like what is a data lake, and then they compare it to the data warehouse. And then this kind of gives you an idea. And what I was talking about earlier of like a use case or who would be using it. A data lake would be used by data scientists and analysts and things like that who are trying to get ideas of what is going on with their data, and so that they can make predictions and better their product for the future. And then same thing would be happening with the data warehouse. It's just a little bit different with how you're putting in the data and then how you're using your data afterwards, as far as like preparing it and everything beforehand. Oops, sorry about that. Something pop up there. Okay. So we're talking about the value of the data lake. Again, to do analysis of our data so we can improve our product, and some of the companies that are using it on AWS right now are Netflix, Zillow, NASDAQ, Yelp, iRobot, and a few more. And you can imagine like the amount of data that Netflix and Zillow and stuff like that would have whenever they're doing their analysis on presenting you better house prices for, or like predicting like what the cost of your mortgage would be based on the historical data of all the houses, or Netflix doing like the recommendation engine and using their data lake to help bring up that historical data and compare to that whenever they're building their machine learning models. And so you want to have a good place to store this data to where it can scale and be affordable. So that's why you'd use a data lake in S3. So this just kind of goes into a little bit more of pretty much what I just said, talking about improving our customer interactions and improving our R&D innovation choices. And then another one would be using IoT devices, because IoT devices are basically streaming data into your application at all times. And so you want to have a way to like store all that data and then filter through it and use it whichever way you like, learning about what your IoT devices are doing and getting more insights onto that. So for our project today, like I said, we're going to use the Star Wars API. And so how I have this set up right now is we're using the Amazon Event Bridge, and I needed to, I built this over the weekend, so I needed to have a way to get a mass amount of data in here. And I realized using the Star Wars API is probably not the best way to do it because their API is consistently the same data, but it is a lot of data that I've accumulated. And so we can show how this glue job and processing takes place. And so what we're doing is querying this API every 10 minutes, and I'm taking that data and I'm going to throw it straight into an S3 bucket. And how I name these S3 buckets, I like to use the same S3 bucket for all my data. Some people are controversial with that. And like to separate their data between different S3 buckets because they think it's better to organize. Personally, I think that different directories in S3 is plenty enough organization as long as you are writing your code appropriately and are able to place it in the right spot. So we're putting all of our data, depending on the endpoint, like planets, people, starships, in the appropriate folders. The reason that this is called raw_people or raw_planets is because we're going to use a glue crawler to build our schema from our data. And that glue crawler is going to name a table in Athena. So let me explain this and I'll come back and explain what that means. But it's going to take that name of my folder and name that table. And so what all that means is that a glue crawler is this tool that AWS has that runs a bunch of Apache products behind the scenes. And it goes and looks at all my data and my JSON, and then it can pull out all the key value pairs and then build a schema out of that. And then that schema creates a table underneath the database in Athena. And what Athena is this way to query S3 data. And so it almost makes S3 look like a database, although it's not. It's just JSON files, CSV files, Parquet files, whatever data you have. But it makes it look like you're actually working with a database. And so this adds a new table. If you're thinking about like a relational database, it adds a new table to your database in Athena. And then my names for this would be the name of this folder right here. So that's why I named it raw starships, raw people, because as I go through my ETL job, and I'll explain this in more depth whenever we actually look at the code, but in this ETL job, what I'm doing here is converting a bunch of JSON data into Parquet. And the reason for that is the price difference and the speed. And so Parquet changes your data into like a more column-based format. That's a lot better for optimizing your queries and increasing or reducing the cost of everything because it can go more granular with the search. And so we want to do that with large amounts of data because if we're querying JSON all the time, it's going to become very expensive and not able to scale as well. And so then this job then puts the new data back into an S3 bucket. So you have to tell the location whenever you're doing this job. And then for me, I specified that instead of the raw folder, I want to put it in the root of Parquet. because that's what type of data this is. It's still Star Wars data. So in an example, you could have had Star Trek and Star Wars and done a comparison with them both. And then again, I call it Parquet planets because this data format is Parquet instead of just the raw JSON. And I could have called this JSON planets, but I know what my raw data is. And then again, we need to create another glue crawler. And the reason for that is because we need to create another table with the Parquet data so we can then query it and actually do something with it other than just having this nice, pretty data. We want to actually be able to use it. And so you're not able to query it until you make a table so Athena can see your data and do something with it. And so we needed to create another crawler that's going to look in this directory inside of S3, build another table, and then if we go to the Athena dashboard, we'll be able to see 6 different tables, 3 of the raw, 3 of the Parquet, and then we can go ahead and run some SQL queries and do some analysis on that. And then down here at the bottom, really quick, you want to do some kind of automation job for this. And so I want to make it so that I don't have to go in there and manually recreate steps. And so what we do is create a glue trigger, and that trigger works with inside of a workflow. And the trigger will call upon the glue job. And so what happens is I have all these crawlers that run, crawl the data initially, and then I have this new raw Starship, raw people, raw planets data inside of Athena. And my glue crawlers have created my tables, and I need to recreate this job every day because, like we said before, I'm querying my data every 10 minutes. And so I just have this glue job to run every day because I don't have, in my example application, I don't have the needs to go and run this every 10 minutes to do my conversions. Once a day is plenty for me with my business analysis needs. And so we're going to run this automation job every day at 12 p.m. and then our task will be complete, and then we'll be able to go and see our data and query it again. So I got a question really quick from Bruno on the YouTube stream. He says, hello, I need to consume an API with 3 million records. The API is paginated to return 50 records per page. From these records, I want to get which product was sold the most. How can I do this? So we could get really nuanced into this, but you would pretty much repeat the same process of getting your data into, this is just the point of this whole task right here. You could simplify it, but we're trying to reduce cost and optimize our data, which is why we're transforming to Parquet. This isn't a necessary thing to actually query your data, but how you would do that to get more insight onto this data is have your data in the S3 bucket, get it from whatever source using a Lambda or however else you're going to get your data, and then put that data in S3, run a glue crawler so that you get your schema built out that builds your table for Athena, and then you could go and write SQL queries against that data right then. And then you could get more insights onto what's going on with your data that you have. Anybody have any questions on any of that? Okay, so let's go into the AWS console. If you guys don't already have an account or need to set everything up, I've got in my repo right here, which I posted in the chats. If you guys need me to post it again, let me know, I can. But in the README, it goes over all the prerequisites that you need to have, installing everything. I wrote my application in Node.js, and then everything else is in AWS SAM for our automation. And then this kind of shows you what we're building, the build steps. And so you can go after this talk or whenever you have time, and you could go and pretty much rebuild all of this. And so I'll go ahead and talk about the code, and then I'll explain our architecture again in AWS, because this may help answer any questions that you guys may have had through that long explanation. But pretty much in this repo, if you guys have worked with AWS, usually you want to put everything in CloudFormation or Terraform or some kind of infrastructure as code, so you're able to repeat your process. So everything that we built here is pretty much serverless. So I'm using the serverless application model, which is called AWS SAM. It's just a layer on top of CloudFormation to make it so that I can write things with less code and achieve the same job. So pretty much what we have here is just an S3 bucket. I have a Lambda layer with Axios, which is a way of how I'm making my API calls to the Star Wars API. And I just have 3 Lambda functions, and I set them up to run on a cron of every 10 minutes. And that's the gist of this folder, is All they're doing is deploying a few Lambda functions, 3 Lambda functions and an S3 bucket, and then the IAM roles to give them proper permissions to execute whatever they need to execute. So nothing too crazy with this. And then this is set up in a way to where you can copy and paste this into your own applications, change the names around if you want, and deploy this again, no problem. So the layers, this is something a little bit out of scope for this, but this is where I have Axios defined. Not going to get super into that. It's more like Node.js talk. This is where my Lambda functions are at inside this functions. These are all pretty much the same thing. I chose an API that was extremely easy to work with. So almost every single one of these functions looks the same. All I'm doing is calling my Star Wars API, putting it into S3. That's all we're doing. We're putting it under the raw Star Wars raw people, and then I'm just naming it based on the timestamp. So then the good part of this, the more meaty part, is how did we build Glue? So I didn't build Glue in CloudFormation. Whenever we were building our data lake for Photobucket, we had some talks with some of the Glue team and how they recommended to do this, because if your application and your data starts to get really large and you have a bunch of different data sources, then deploying this in CloudFormation can do that. You would just need to go update things all the time and make sure that you have your configuration set of all your different S3 paths. But instead what they asked, or what they suggested that we do, is create like a JSON folder or a JSON file and just declare all of our different paths and everything. And so I have the name of my crawlers, the name of my paths for both Parquet and for the raw data. And so this is pretty much the root and the meat of this entire Glue configuration build. It defines like my database, and this IAM role is hard-coded. From this template, I created this in here, this Glue role. I took the name because I knew what the name was, and I put it in my template. So in order of building this, you would want to deploy your template first and then start building your configuration. And then my S3 paths, like we said before, just the name of my S3 bucket that I deployed in the template, and then those paths. So you could just change this name to whatever you would like for your S3 bucket, because S3 bucket names are all unique. So you're not going to be able to replicate this name exactly, but you could like maybe change it to be whatever you want your application to be. And so this is just, this crawler data is just this array of objects. And so how I use this is I have all these tasks, and these tasks are just using the Glue SDK. And I'm using the Glue SDK to deploy my crawlers, my job, my workflow. And we want to do this on the SDK because it's a little bit easier than deploying it all in CloudFormation, more or less. And it's still automated because these steps are all written and they're going to be repeated to be the exact same every time. So this is just going through the SDK a little bit. I'm not going to go through all of this. This Json classifier is important to go through, though. It's really weird syntax, but pretty much this makes it so that whenever I'm deploying or whenever I'm crawling through a bunch of JSON data that's like deeply nested, which this data wasn't super deeply nested, but it had enough layers to where I felt necessary to use a classifier. The classifier makes it so that my Glue crawler, whenever it goes through and combs through my data, can pull out each individual key pair and then make that schema for me. And so this is why we use a classifier. Otherwise, everything else is pretty much self-explanatory. I've kind of talked about this quite a bit. We're just mapping through our crawler data that we have in this config. Put this over here. Okay. So we've got this crawler data. We're going to map through it. We're going to build those 3 crawlers, and I'm going to use that JSON classifier and reference that in here so that I can then create my crawlers, and then I have the command to run the crawlers. And that's pretty much the same with all of this. It's just building it and then running it. And then my Glue job, pretty basic, straight out of the box of the SDK, more or less copy and pasted. And we're just have our Glue job going to run like this. So the last thing in this application then is our script. So this is the actual logic that transform our data into Parquet. And like I said before, that transforming into Parquet it's not necessary, like it's not a required step. The purpose of that is to optimize our data so that whenever we're doing queries, we increase the speed and we reduce cost, most importantly. because querying a bunch of JSON, whenever you've got gigabytes on gigabytes and terabytes of data, can be really, really expensive. And then Athena may not be worth it for you. But transferring to Parquet can save like 90% of your cost. It's substantial. So this is a basic template. Whenever you're building a Glue job, and I'll walk you through that in just a moment. Glue writes this Python code for you. It's like Spark, and just does this like basic structure for you. I modified this a little bit. For the most part, it's pretty much the same. I just did it for all of my different data sources and put it into one job. So I can have one job run. And you might ask, like, why would you have one job but multiple crawlers? Because crawlers can crawl multiple data sources at the same time. And the reason behind that, well, you could separate it to be multiple jobs that run one data source, one crawler, one job. The reason why I have it set up to where it's multiple crawlers in the one job is my job works efficiently. It doesn't take a very long time. It's not that many data sources, and it's not complex enough to really break my job. But with the crawlers, I've had issues to where since it's looking at all these different schemas over and over again, and it's one crawler doing it, the crawler can get confused. And I'm not 100% sure what AWS has behind the scenes of this that would make this happen. But whenever you're running multiple different data sources, like if you had CSV data and JSON data and you ran it all together and you wanted to run all of that in one crawler, I mean, it took sometimes like 25 hours before it failed. And so it would just run for an extended period of time. And if you break it out to where it was just CSV and just JSON and just that one schema, and it was individual one-to-one ratio data source and crawler, it runs a lot faster and a lot more efficient, and it's more accurate with your data and your schema that it builds. So that's kind of the reason why we've defined 3 crawlers in one job. Any questions on any of that? Sweet. Get to this. Okay, so open up a couple tabs. Go look at S3 first. So I've got my Star Wars Data Lake. So like how we saw in my folder structure, I've got raw and Parquet, and then I uploaded my script in here too, so that my Glue job could reference it whenever it's being created. So my raw job is just like we saw, all of this, and then I've got a bunch of different data in here to show my, every time that I'm uploading data, I make a new file in there. And so that's run for the last every 10 minutes for the last like 5 days. And then same thing with the Parquet. This is automatically inserted by AWS Glue. After it runs a job, it automatically inserts my data into these directories because I told it which directories I wanted it to go into whenever I defined my job. So the S3 structure is pretty simple. So whenever you're looking at AWS Glue, you've got like your data catalog and your database. And so what we were looking at earlier is this AWS Meetup database. And this database, if you're looking at it in Athena, go away. Stupid thing. Open this tab. So if you're looking at Athena, you can actually see what I'm talking about a bit better. Data source, database, AWS Meetup Group database. Oh, actually, it's this one. I've created a couple of different ones. So we've got our Star Wars database, and we've got our tables underneath that. And like I said before, we have our 6 different tables. And the reason for that is we've got our initial 3 crawlers of the raw, and our after we run our job, then we have to recrawl and get our Parquet data. And so this kind of looks like how you'd picture a weird GUI of an actual database structure to be, which is what they're trying to replicate, although it's just files in S3. And then whenever you run it, you can actually see all your different data that came from an API, and you could go and do whatever analysis that you want onto this, like something with your cost and credits. I don't know what that data is actually about, but you get the idea of like going in and doing manipulations on this to get insight for your business needs. So that's kind of what this database shows, and all of our data underneath that. And then you can see the tables that are defined, and then these tables are related to the database. And then it's got the location that we just looked at. So it's really easy to see what all my different data is. And then it even tells you the classification of data between JSON and Parquet, for our example. And you can have CSV or whatever else in here. In my experience, working with Glue and CSV is much easier than working with Glue and JSON. Sometimes the JSON data, if it's deeply nested, can be kind of a pain. But CSV and Parquet, whenever you query it, they look pretty much exactly the same. And so running it through Glue, it's not nested, so it can pull out each individual name very easily. So then we've got our 6 crawlers. Crawlers relate to our tables and to our different data sources. And so these all took about a minute to run. So it ran pretty quickly. And let me look into here really quick. So jumping back briefly, if you look at what I was talking about before with those pulling out our different names from our data, our JSON data had these different values. It actually had more. I deleted some of them because they were just not necessary for my data, but for my Parquet data. Now, whenever you're creating the data lake, you usually want to preserve all your raw data. So in my /raw directory, all of the other fields that I removed from my Parquet data would still be in the raw, just in case I needed to go back and use that for whatever reason. It's there. You don't want to get rid of, as a best practice, you don't want to get rid of any of your data in a data lake. You want to preserve every bit of data that you can possibly attain, just so that in the future, you can go back and use it if necessary, if you need it. So this shows you what my schemas looked like that it built for me and all of this. And then you could see the difference in the JSON, how we have these other fields, because we think we had only 8 in the Parquet, and we've got 16 in here. And these ones I felt like weren't necessary. So I removed them in my glue job and my script. Whenever it runs, it maps the different fields to each other. And how that works is you've got like the name, it tells you what data type. This is actually a little bit redundant. Glue creates this and I just didn't clean it up, but equal syntax would be to go into here and just delete this, and then my glue job should run the same. But the difference in why they do that, let's see if I have a good example in here. I don't think I do. My data wasn't that nested. But the difference would be if you had nested data and it needed to traverse through your JSON tree to make that name. What it would look like is, let's say we had, I think the actual this API returned results was an array. And then within that array was an object of, or a key of name. So then we could call that key of name and then it would map through and it would say, okay, this name is equal to results.name. And I think it would actually look like this. So this kind of relationalizes your data is what it's called. Is this way name is equal to results.name. So then it would traverse through whenever it did this job, it would look at that JSON data and then it would compare it to name. And then whenever you built your schema and everything was ready and we went back and we looked at our Parquet data, it would show that column as name instead of results.name. And then we would be able to query that instead of having this like nested structure, which I can show you here. But what that would look like if you didn't do it. If we did query the raw data and we looked at our people data, let's see if this works properly. Like this is pretty difficult to use right here and this looks terrible. How this is basically just name is telling me that it's all this JSON. And so we can't really use that. So that's the purpose of the job. One of the purposes of the job is to clean this up, to make this to where you can have different columns for these different keys. And then also, again, really trying to bring this home. The purpose of Parquet is to make it a lot cheaper and faster. Okay, so then we've got the classifier here that we talked about, this JSON classifier. It's just literally come in here, say add a classifier, paste in whatever type of data you have, and then paste in that weird JSON path that's in the repo. Paste this in, and then it will traverse through your data a bit easier. And that's why I didn't have any nested structures, was because of that JSON classifier. I was able to go through and create a really good crawler and a really good table with my data. This one. Then it would be like this, instead of just being that long object that we saw. Any questions on that? Sweet. So last couple of things, and then I can show you like how to actually create this in the console. So we have our workflow. Workflow is just automating our entire process. The GUI is kind of strange, but it shows you this little grid. See if I can make this bigger. So it shows you this grid, shows me my Star Wars job trigger, which is something that I defined. I gave it that name whenever I was creating it in the SDK, and it's going to call my job. And that's all it does, is once a day calls the job. And you can see history of the jobs whenever they were executed and see that they were completed. And Monday, Tuesday, Wednesday, Thursdays, for the last 4 days, it's been running successfully. And then you could see like, you could see your trigger in here and see what its definition is. You'd schedule it at 12 p.m. every day, and it's associated with that Star Wars workflow. And that's kind of how that works. You would define a workflow, which is the parent, and you could have multiple triggers within that one workflow. And the workflow would call these triggers on whatever schedule you have per trigger. And you could get granular with it. And then of course, I've got my job, which does the mutation of JSON to Parquet. And that's more or less the gist of our application as far as what we have built right now and what you would want to do with your own application. Yeah, take a couple minutes and see if you guys have any questions.
So Austin, it's Jeff. I have one. Can you give us a feel for, even if it's an order of magnitude, but the kind of charges that companies would see as they use Glue and create data lakes? I'm sure the answer is depends on the volume of data, but you know, are companies typically looking at hundreds of dollars a month, thousands of dollars a month, just based on your experience? Give us a feel for maybe how these costs compare to what a company spends on EC2 and storage.
Yeah, I'm not going to have, like you said, it does definitely depends on what data you have, how much data you have, if it's Parquet, how much you're querying it, so many different variables. So I don't want to give like a solid answer on like if it's going to be hundreds or thousands, because I don't know your different use case. But
yeah.
And whenever we were building our data lake, I left after I pretty much built it and left, so I wasn't there to watch them query it and build up a massive charge, unfortunately. So I don't have a lot of insight onto how much that ended up costing them. But with what we have right now with this architecture, as far as running the Glue job once a day, and I don't have a ton of data, like probably and just a couple hundred megabytes, even though it has been running so much, it's just not a ton of data. I mean, this Glue workflow is going to be cheap. The only place that you're going to get cost, unless you have terabytes of data, is going to be in Athena. And that's the reason why we transfer this to Parquet, because Parquet is like substantially cheaper.
Is that based on execution time?
Yeah, it's based on how much data you actually query. Oh, and then another thing that I actually didn't do in here was partitioning my data, which should make it more efficient as well and reduce cost. And partitioning would be whenever you're in my Lambda logic, when I'm uploading to S3, I could have like my code is all in Node.js, so I can have some Node.js like date set up to say like what year was it, what month was it, what day was it, instead of that partition, and then I could have that as part of my file name for my actual data that I'm uploading. And then Glue, whenever it crawled that data, would still be able to go ahead and build a partition for me automatically based on these different directories I have defined. Let's see if I can figure out if I can find the cost difference. Yeah, they have right here, if you're querying non-partition table costs like this, it's just substantially cheaper and faster going from JSON to Parquet. If you're using like, I mean, they're not doing a ton of data, but 29 megabytes, it's pretty much costing nothing for them to do that. That kind of helps answer it. I know that was more of a diplomatic answer of saying I don't know, but
Oh, anything that's 99 or 98% cheaper. I think that's motivation right there.
Yeah.
I had a
Maybe
question.
go ahead. Go ahead,
Oh,
John.
I'm sorry. I was just curious about what that, on the Glue console, what the notebook was about. It was right on the left side under ETL, it says dev endpoints notebooks. Wondered what that was.
I haven't messed with these enough. I
Okay.
don't know what notebooks are.
Oh, SageMaker. That sounds like last month's talk.
Oh,
Yeah, it
interesting.
does.
Huh. Yeah, I didn't realize that you could create a SageMaker notebook inside of Glue. That's I've never done that. I've never really worked with SageMaker that much. I don't really have much of a data analytics or machine learning background at all. But the hearsay I've heard is to not use SageMaker, but who knows?
Okay.
It gets expensive from what I've heard. That's the only reason. You could put your models into like a ECS container or something like that right there. But maybe SageMaker has some built-in like special features where you don't have to manage it. But if you're using a managed service, you're going to pay for it typically, not all the time, but.
Thanks.
I have a question from the YouTube stream. It says, how does a JSON work with aligning objects and arrays? Does the Glue automatically map them? Yeah, that's a great question. That kind of digs into the classifier. So, oh yeah, let me just show you what a job looks like, and that'll actually answer the question even better. So if you're building a job from scratch, just call it test job. Okay. So this is what basically we're doing now is we're defining an ETL job, which would be for my use case, converting JSON to Parquet. Shows us our Glue version. It's going to propose a new script generated by Glue, or we could provide it one. But for this example, I wanted to give us one, and this will help show you the mapping to kind of answer your question. And then, yeah, going into advanced properties, enabling a bookmark is something that's pretty important to talk about. It's actually really important to talk about. So if we're looking at this diagram again really quickly, I don't have an automation step or a trigger for my Glue crawlers, which seems like I'm missing something because how is my data going to get crawled again? Because I have all the new data and I need to continue crawling it to build my job or whatever, right? That's the question that I had when I was first building this. Whenever you're enabling these bookmarks, you no longer have to do that, and then it bookmarks your data, and then whenever you run that ETL job, it goes from where your data was last at. Instead of re-looking at all of the data again, it bookmarks where you're at for your last job and then continues the new transformation of data from where it left off the previous time, looking at all the new data. So that's actually really important to use whenever you're in production, is to enable bookmarks. It will save a lot of speed with your ETL jobs and money. So we could choose a data source. So if I was going to go from my people directory, and let's say I wanted to change a schema, I would create a table in my target, in your data target. Instead of using it from a data catalog, we would go select Amazon S3. We're going to transform to Parquet. We don't have a connection we need. Then I would tell it a directory. What's my bucket name? Okay. We'll just call this like Parquet Star Wars people test. Okay, so then this shows you how that data, after it was crawled, it's mapping to what it's going to look like in your Parquet schema. And so this is going to be, this could be different. And if this was a lot more nested, unfortunately I don't have an example of that with the data I have, but if it was a lot more nested, you could bear with me and picture this. You could picture an arrow drop down right here. And let's see if I click that arrow drop down, this would be an array. Like it should have pop up here, but it's not for whatever reason. But I could click that arrow and it would drop down and it would show me all the values in this array. Or it would do that if it were a struct, if it were an object data type, not an array. So if it were like an object, it would drop down and show me all the different fields underneath my home world object or my films object, if it were an object. And then I could type in, like click in here, you could change this and say it maps to species or whatever. And then it would change that arrow and kind of show us visually where that my films is going to be equal to species instead of it being films to films. And obviously that doesn't make sense, but you kind of get the idea of like how that mapping would happen. And then what I would do, if I wanted to save time or if I wanted to be lazy and not write all this Spark code from scratch, let's say like I want to make this a little bit shorter and not have all this data like we did before. Oops. So this is what I have in the schema that I created. So we'll kind of replicate that. So then I could save and create the job. And it's just giving us tips on like how to use this editor. So it gives us like a built-in editor right here, and then it shows us what all is going on the left-hand side, kind of on like this nice little pretty format. And so then you can come in here and mostly copy and paste this code and build a larger script and then build a job and have it run all your different data sources and convert them at once, which is exactly what I did. So that's kind of how you would start to do that conversion of all of your data. And you're talking about aligning objects and arrays. Yeah, that was pretty much how I would do it. How I'd done it is just go in there to the console, and then I could get that basic boilerplate code. And if I'm not happy with it, then I at least have this to start with. And I could go in here and change this and make this and improve it and add more logic and do whatever I need. But at least I'm not starting from scratch. So that's kind of what I would do. And then I just delete all this comments and oops, I hit something. Okay. Yeah, I would just delete these comments and then copy this to a bigger file that is my glue job. And then I could modify it and run it all, or I could separate it into where it could be one glue job per data source. And then we could save this. And in theory, we won't have any errors, but doing it on the fly, we're bound to get something that breaks. But then it shows you like your path. So this is where it's going to go. So if this runs successfully, all of our data should show up in this directory in S3. Format's going to be Parquet, all of that. It shows us our mapping that it defined for us from that last page. And if you saw, there's like 16 different fields. And like I said before, this is redundant. This doesn't need to be like that. It can just be with just the one mapping, because these are like basic data structures, all strings. But we only have like 8 in here because we deleted some. And so you can modify it in that GUI, come in here and actually write better code and update it, which I think helps a lot. So yeah, then this would run, apply the mapping, and then you would have all that data in your S3 bucket for the Parquet, and then you would need to run another crawler. Sweet, it's already started to put some of that data in there. So we've got our people test data, and this, it's still running that job, so this is probably going to get deleted, but then we'll have, it will look something like this, and we'll have just like all these Parquet files, and then we'll run that job, we'll run another crawler, and then we'll have it, and then we automate that process. So this kind of manual-ish steps only happens once, and I'm sure there is a much more efficient way of doing it. This is kind of the advice that was given to me from the Glue rep, but I mean, it's pretty simple. You run a runt, you write everything in your SDK, or you could go do the painful route of writing all this Glue into CloudFormation. Either way is fine. And then you know you have the workflow go, and then you pretty much are hands off for the rest of the life of this data lake, unless you have a new data source that comes in. Then you just need to write your Lambda logic, put in S3, and then maybe update your Glue script for this ETL job, and then send it off to your data scientists and let them get some better analysis on your business and everything.
Hey, Austin, we have a question from the Meetup group from Gustav. He wanted to know how Glue compares to AWS Lake Formation and maybe which would be easier or reasons to use one versus the other.
I think they're like, Oh, okay. So this is just like a layer. I think I've never used lake formation. I'm pretty sure this is just like my idea of lake formation, and I'm talking out of my ass, full transparency. I've never used it. Is if you've ever used like Elastic Beanstalk, that's what I picture lake formation to be. Is like pretty much doing the exact same thing as what we're doing, but kind of hiding the steps from you. But I'm not sure. I've never used lake formation. I have no experience with it at all. I can't confidently answer that question. But yeah, I don't know the downfalls of it. I don't know much about it.
All right, Gabriel, if you wanted to comment, I know you put in the chat window, that's correct. But if you have any background on that, Gabriel, and you wanted to unmute, that would be fine.
Yeah, go for it. Oh, sorry. The question for everybody on the YouTube stream was, what's the difference between lake formation and AWS Glue, pros and cons? My answer was pretty much I don't know, but it seems like they're doing basically the same thing. That lake formation is hiding a lot of the configuration and build steps from you and kind of automating that, similar to Elastic Beanstalk would be if you were to stand up a application on EC2 or whatever. Yeah, if anybody had a better explanation of that than me, feel free to jump in. Like I said, I've never used it, but let's see if this finished. Okay. Pivot back to this, our Parquet data, our people test running that ETL job. It just finished. See all of our Parquet data. So I'll go ahead and run through just really quickly what it would look like if you ran the crawler. So we'll create a new crawler, just to show you the steps behind that. I think it always helps to visualize it. So this would be our test people crawler. We can add this classifier. We're only using Parquet data, so we don't really need to, but if I were building another JSON, if I had another JSON data source that was deeply nested, all I would need to do is click add. And I hit next. And then we just tell it where that data is at. See, here you go. You could add another data source and you can run everything in one crawler. But like I said before, and AWS recommends against that because it can confuse the crawler. Just one crawler per one data source. Otherwise, your data will get, it can take a long time and then it's not very efficient.
I think David's mentioned another alternative would be step function, mentioning you have more control on each Lambda, but you need to write the code for everything.
Using a step function instead of this whole process?
Unsure what he means by that.
That's my guess. Yeah, that's definitely a very valid alternative, 100%. You could just have a step function that would do pretty much all of this. This is just more of using AWS's managed services, and it is very easy to stand up once you kind of grasp like the basics of the data lake and what you're doing with your data. This is just a lot easier because you don't have to write all the code, but I'm with you. I'm a developer. I like to write the code too. Whenever I was at Photobucket, I kind of pushed for me to write the code and I was told no. So that's why I got to learn how to use Glue pretty well. So, but yeah, you could do all of this with step functions and have it automate the whole process.
Hey, Austin, I think we've got Gabriel who works for Amazon AWS back. I know he had an issue with Zoom, but Gabriel, if you want to give that another shot to explain lake formation, that'd be great.
Yeah, sure. And sorry about that. I don't know why it just froze as soon as I was trying to come off of mute. But yeah, basically, lake formation is a pretty new offering from AWS. But I really like the analogy there of it being similar to Elastic Beanstalk, and that's exactly what it is. It's basically you know, kind of tying a bunch of the services that are working in the background, things like Glue, S3, Athena, those kind of services together that allows you to easily create a data lake in AWS.
Right on. Yeah, that's what it seems like. My experience with it was opening this this doc right here. So that's about the extent of my knowledge of it. But yeah, so I guess if you're like just getting started and trying to figure out what you're doing, it'd probably be a good solution. But I don't know. I'm not a big fan of Elastic Beanstalk personally, but maybe some people have different stories and got a lot out of it. I had a question on the YouTube stream about, is there a simple way to generate a CSV report in Glue with the result of the executed query and send it to an email, or do I need to do this via Lambda? So I need to ask, are you talking about if the job, after the job is finished, to send you an email that the job has been finished? I don't think that there's a way in Glue to go ahead and send that event and then have it be like, yeah, it's done. You could probably have like like maybe you could trigger, I'm not sure if it's an event source for Lambda or not, but if it is, then you could have, whenever it's finished, trigger your Lambda function, and then your Lambda function would have the logic that would send you the email. But I don't think that Glue is going to send you an email. I'm also not sure if it finishing the job would be a way to trigger Lambda either. I've never needed to do that, but that's a good use case. And then after this crawler runs, I'm pivoting a little bit, but this crawler was our test people crawler. After we run our job that we just created, this should go ahead and build our Parquet data and then put that into our Athena table. And then we will be able to query all that new data. Any other questions about all this stuff?
So Austin, I know you had posted your GitHub repo at the top of the chat window, but maybe if you want to just remind people that that's there and how it has instructions for people to kind of walk through this, this example project.
Yeah, for sure. I'm not sure. Where's my chat? There we go. We can post this back in here. Okay. Yeah, so if you guys wanted to go through this, I think this is like a good starter place. I probably wouldn't use this like directly in production for your application. It's kind of like, it's not far off, but maybe a little bit of modifications to make this production ready, securing some of your stuff, maybe improving that config file, because this is kind of small. And my Lambdas, again, are like pretty rudimentary. They're not doing much. But this gives you a good overview and idea of like what a data lake is, I think, and kind of gives you an idea of like how to expand this into something else more conceptual, I guess. But yeah, so all of this has the instructions, and if you guys have any questions about this, like feel free to reach out to me on LinkedIn or message me on the Meetup group or anything like that. I'm gonna give a shameless plug for the Meetup group really quick. If you guys want, come check out AWS Meetup Group. We've been around for, I don't know, a year and a half, almost 2 years out here in Denver. So
I've recorded everything, guys, as well, right? So I'll make sure to post this onto my LinkedIn so you can re-watch this and have a look into detail. And if you've got any questions on his repo or anything really that you didn't think about that you'd like to revisit, then I'm sure he'll spend his time to help. Thanks, Austin. That was really good, mate.
yeah, I think just to show really quick, hopefully it shows up really fast. Should be here soon. It's not there yet. Yeah, I was going to show that the finished up of this whenever this stops, hopefully soon. Then you can see the other table pop up, and then yeah, do whatever you want with it. I'm the person that can get the data there, but obviously my query is pretty basic, so I'm not the one to talk about what to do once you get the actual data. That's the idea of the data lake.
So Austin, other than your GitHub repo, any recommendations for online resources, maybe whether it was a Cloud Guru, or do you have any recommendations for people who want maybe some online training and exposure to more information?
Yeah, I'm not sure if ACloud Guru has a course or not on data lakes. I'm sure they do. They've got a course on everything. If they do, then by default, I'd already say that that's a good place to go if you guys have a subscription, because they always have like really easy to follow stuff. Otherwise, for me, I personally just comb through a ton of documentation. I didn't have anything in particular, nothing good to plug. Yeah. Do you know if they have a course on data lakes or not?
I personally don't. Gabriel, do you have any recommendations for online data lake training?
Yeah, so at AWS, we do of course have some. I'm actually checking A Cloud Guru. I haven't seen one on there or on Linux Academy. They do have big data courses though that are pretty good. If you are just looking to learn about things like Glue, Athena, Redshift, even EMR. So I would probably suggest starting there. I'm not seeing a data lake course on here, and of course we also have workshops that I'm looking at here, so I can post in the chat to see if I can find something that would be useful for you all if you're just kind of looking to do some exercises or kind of build like a data lake for yourself, just to learn the services.
Sweet. Yeah, right on. Yeah. Yeah, like I said, if you guys have any questions, like feel free to reach out. Otherwise, I'm gonna go ahead and close out the stream on YouTube. And yeah, like I said, if you guys want to come check out any of the events we're doing, we usually do them at least once or twice a month. At the end of this month, we've got somebody talking about how to reduce your costs on AWS. It's this company called Cumulus, and they have a good product, and they're kind of showing like an example production architecture in AWS, and then showing like how to optimize it even more and how to get insights and all that. And then in October, we've got somebody going over machine learning ops in AWS. And he's got like 7 years of data science background in AWS, and so he is going to walk through building. Since we're in Denver, he's going to be building some way of showing you best ski resorts to go to at a certain time, I believe, with his machine learning model, and then showing how that's all deployed and everything on AWS. Otherwise, yeah, see you guys in a couple weeks.
Thanks, Austin. That was yeah, nothing short of a pleasure. Lovely to see you all as well, guys. New names, same names, similar names. We're obviously doing the same next month, and we'll make sure to market that out to you guys and push that out and talk about the speaker in a little bit more detail. But Austin, that was really great. Thanks so much.
Yeah, right on. Thank you. Thanks for having me.
Enjoy the bolts game, guys. Fingers crossed. 3-2. If any of you like the bolts, it looks like our death there. But we'll make sure to keep comms open, guys. And like we said, like if anyone's got any recommendations for, if you want to do a talk or talk about your company or talk about something you're implementing that's really interesting, that's local, we want to hear from you. And I'd love to think I can connect with you all. So I'll put my details in the chat, and yeah, until next time. Yeah.
All right. Everyone have a good night.
Peace and love.
See you guys.
Thanks, everyone.